Some reactions are irreversible. That means they can occur only in one direction. For example, if you add sulfuric acid to sugar, then the carbon that was in the sugar separates from the water that was in the sugar. The water comes off as steam, the carbon rises in a big black mass, and if you were to add the water back to the carbon, it would not combine back into sugar. This reaction cannot occur in the reverse direction. Only in the forward direction it is irreversible. On the other hand, some reactions are reversible. For example, if you take blue hydrous copper sulfate, which has a crystal of CuSO4.5H2O, meaning that there is water of crystallization within the crystal. And if you were to add sulfuric acid to that, the sulfuric acid dehydrates the blue hydrous copper sulfate, changing it into the anhydrous white form, which lacks the water of crystallization. And the water of crystallization goes off free. That's the forward reaction that I've just described. But if you would add water to the white copper sulfate, then the reverse reaction would occur. That white anhydrous copper sulfate would change into hydrous copper sulfate. The reaction can occur both ways. It is reversible. Another example of a reversible reaction is evaporation. Water liquid can be heated and change into water vapor. Water vapor can be cooled and change back into water liquid. A term we need to understand before we can understand equilibrium is closed system as opposed to an open system. In a closed system, there is no interaction between the system and the surroundings. That means that products either don't or cannot escape to the surroundings. The opposite is true for an open system. Let's look at the example shown here. A gas is produced. It is one of the products. If the test tube is open, that gas can escape. There can be interaction between the system and the surroundings. So this would be an open system. If we wanted to make this a closed system, we would need to put a stopper to seal this in the mouth of the test tube. Then the gas would be unable to escape. Then this would be a closed system. However, you must be careful because a closed system doesn't necessarily mean one that is closed with some kind of lid or stopper. In B, no gaseous products are formed. Maybe only liquids or solids or solutions are formed, and none of those are able to rise and escape. And so if no gases are produced, it doesn't matter whether we have a stopper or we don't have a stopper in the test tube. None of the products are going to escape anyway. And so this system would also be closed even though there's no stopper.